The Wonders of Electromagnetism
by
Garrett
and Alan.
Electromagnetism. What is it?
The interaction of electric currents or fields and magnetic fields.
Electromagnetic induction. What is it?
It is the production of a potential difference in voltage across a conductor when it is exposed to a varying magnetic field.
So, for example, in this setup we have a galvanometer which measures electric current connected to a wire coil which is a conductor.
Additionally, we have a magnet that produces its own magnetic field. When the magnet moves in and out of the wire coil, an electric current is produced.
This current is produced because a difference in voltage is produced when the magnetic field is intercepted. This is also known as a change in magnetic flux. Magnetic flux. What is it? It is the number of magnetic field lines intercepted in a certain area.
This is the magnetic flux equation. Magnetic flux is symbolized by this phi symbol, and it is literally the magnetic field lines times the area. In our demonstration, we'll show that the magnetic field lines of Earth, which are all around us, can change and create a current with this giant wire coil and this massive galvanometer. As we move the coil, a current from the magnetic field lines is detected over here, and the galvanometer detects that as shown. This little contraption detects the Earth's magnetic field. Here it shows that the southern end is pointing towards the north, and the northern end is pointing towards the south, like shown. If the magnetic field lines go in this direction, then a lot of magnetic field lines can go through this one because of its large area. Fewer can fit through here due to its angle.
As you can see,
As we rotate it, the magnetic flux changes. And this, of course, causes current. Even though Earth's magnetism is several thousand nanoteslas, it's hard to see on the galvanometer. But if we use this magnet to symbolize the magnetism of Earth, we can clearly see how shifting the coil can create electricity.
Lenz's Law. What is it?
It is an induced electromagnetic field in a closed conducting loop. Always creates a current whose magnetic field opposes the original change in magnetic flux.
So Lenz's Law also includes the right-hand rule, RHI. And this states that the whatever way the magnetic field is going into the wire loop. So in this case, the magnet, because the north end's going in, the magnetic field runs this way. So take your right hand and point your thumb in that direction, and whichever way your fingers curl is the way the current flows. So the current on this loop would be flowing this way.
Earth's magnetic field runs south to north. According to Lenz's law, the current that is produced in the coil produces its own magnetism, and that magnetism runs north to south.
The end.